Hi, I'm Andrew Kamphey. I run bettersheets.co. We're going to go through automating spreadsheets. We're going to learn AppScript. We're going to learn how to use AppScripts again and again and again. In this particular section, I've put in a few videos that'll help you later on. They go through fundamentals of AppScript that I think are very, very important. I've taught this kind of material a few times now, and almost every single time the questions comes up about parentheses, about function syntax, about variables, about CamelCase, dot notation, all sorts of little things that I end up spending 5 to 10 minutes in the course sort of going away and teaching. So I've put these up front so that you have these fundamentals down when you start. But if you end up skipping them now and you go through the course and you're like, but what is this dot thing? Or why is there a parentheses? You can always come back to these later on and watch them. I also share with you some errors that might occur if you don't do it the way that AppScript wants you to do it. So just in case you see those errors, you can also come back and see, oh, is one of these errors in here? So this is all to help you, and if you have more questions, feel free to reach out, ask the questions, especially if you get further and deeper into the course, and you're like, hey, what is this thing? I can always add it later on. So I really wanted to get you going. So yeah, enjoy the pre-course videos all about the fundamentals of AppScript in Spreadsheet Automation 101. All right, so this video is all about how to think like a programmer, how to develop a mindset like a coder. You're learning AppScript, you're learning the code behind Google Sheets, and I wanted to give you sort of an overview and some tips, at least advice, over how to think like a programmer. Now that I've been doing it for many years, I really wanted to go back and think about like when I knew nothing, or I tried some things, I attempted some things, and I was like, oh, it was always like complex, and it always seemed like everything was ahead of me. Now I still think everything's ahead of me, but I've always heard bad advice as well. So I want to actually go to ChatGPT and ask how to think like a programmer. I bet like the answer is going to be like something like break down the problem into simple like parts, like atomic elements. Exactly. Okay, it said it involves problem-solving mindset, break problems down into smaller parts. Yeah, because complex problems can be overwhelming. Analyze the problem, come up with a plan. Yeah, this is all the kind of advice that I hear all the time. And it's terrible advice. Like, it's just pure, like, it doesn't make sense when you are starting. This kind of advice doesn't make sense when you know nothing or you know very little how to, like, think like a programmer. This is the basic, the common advice. And AI just proved it, right? AI, ChatGPT just sort of went through all of the advice and got like the most common advice. And it's so trite and it's ineffective. You can't analyze the problem if you don't know how to code. Like you can't come up with a plan if you don't know what to do, what elements are the basic elements, and testing the solution. Okay, that's on the path, sort of. As you implement your solution, be sure to test it to ensure that it is correct and effective. Be prepared to iterate. Yeah, like iterating is good. Making changes, be flexible, understand the problem, and you're going to like figure out the solution, right? Document your work. Like, okay, it's fine for like working programmers. Like this is all fine and well if you are in the mode of working. But if you're just starting out, right? Like I'm trying to help you get better at AppScript. And I think this kind of advice is just terrible. So I came up with my own advice. And again, this is coming from a few years of programming myself in Google Sheets. I wanted to think of and recall sort of what are the actual steps that I did. And maybe this is more like habits of a programmer or like good things to do, good behaviors to have. The mindset, my personal belief is that the mindset comes from the actions, right? Your behavior will show your thinking. So let's just get started. Enough with the talk, enough with the introduction. I thought that ChatGPT would be very helpful, and it was, to show me what is considered the best advice. But here's my advice. All right, the first thing I would recommend is don't memorize. Do not think that you will remember everything. And literally, you cannot remember everything. So one of the practices early on I did was I would just read the documentation through and through and like try to memorize all of the options. Don't do that. Now, that did help me understanding what is available. But what I really want to get across to you through this course and through more videos about AppScript and more videos about learning to code is learn the process. Watch the process, right? As I do things, I might go over to Google Help, or I'll use IntelliSense or like the autofill. I'll use the autofill because I won't remember, is it get active spreadsheet or is it get active sheet? I didn't know that for years, and I just tried, which will be another, that's a spoiler alert. Figure out how to search. I routinely, when coding and when programming in AppScript, I will literally go to Google a lot because I just don't remember the syntax. I don't remember this, but I know that it exists. I know there's documentation somewhere online, and I have to figure out what to search for. Literally, I have to know, okay, early on I was looking for gas, G-A-S. I would add that to search my search. I would type in a word and then add gas. That didn't help. I had to type out Google AppScript, or yeah, now that's what I do. I sort of look for, I think of the action that I'm trying to do, and then I add Google AppScript at the end of the search. And more times than not, I'll get a Stack Overflow. I'll get some results that even if I didn't get the exact, I tried, and I'll try to figure out the actual words later. So don't memorize the code, but do remember and try to figure out the words and phrases that are used. Like in Spreadsheet Automation 101, I talk a lot about like functions, arrays. These are things that come up literally all the time. Like literally every single time you're coding, you're working with functions, you're working with arrays. Know those words. Know those particular words that come up all the time. And you don't have to sit there and memorize them. One of the hardest things for me when I was learning to code other languages is the first set of material would be a lot of defining a word and then telling you what that word meant, but I didn't understand the context, and it was very hard for me to understand, when are you going to use this? How are you going to use this? Well, what I realized now, years later, is that those words were great to say, okay, is there a function to do X? How do I access the first element of an array is much easier to search for, and you'll get the right answers than how do I get the first thing in a list, for instance. If I know the word array is a list of elements, great. Now I can search for array all the time. So watch out for the words and phrases that I use in Google AppScript and in these videos, and understand, like, perhaps you don't need to memorize what a function is, what an array is. You're going to work through it. The second thing I will say, and I would say let's try, that's sort of a mindset that I have, is just go for it. Like hit save, hit run, put that function inside your Google Sheet and just try it. Just go for it. Give it a go. Give it a try. Get the steps that you're working through into your muscle memory. So just like I said, don't memorize. Don't try to memorize. Your muscles are going to remember. So your muscles are going to remember, okay, hit publish, hit save, hit run, go for it, go for it. Your muscle will get that memory. And there's lots of tools that exist to catch errors. There's logger.log, there's try catch, which I don't actually use that much, but it's extremely useful if you're like, I don't know if this particular code will run, so you can put it inside of a try catch and then catch the error. Sometimes the error code will be in a weird place, so just find out where that error code shows up in the log, in your screen. It'll give you a big red bar. And there's lots of debugging tools in coding in total, but also in Google AppScript, which brings me to seek errors. This is the third advice I would try to imbue upon you, is do not be afraid of errors. They're like tiny baddies along the way on certain like smaller early levels of a game. Like these are things like if you see a baddie, you know you're on the right path. Like if you don't get an error and like nothing happens, you're like, oh, what happened? Like you don't know. Seek out the error. Try to change your code early on when you're coding. And if you watch some more of the videos in Spreadsheet Automation 101, check out what error occurs if you misspell something or you don't use a dot. There's a video called Dot Notation, right? All about the dots. Take a dot out. Run the code. See the error you get. And get familiar with the fact that you're going to see errors. Now, here's something I will go backwards a little bit. Search for errors. I don't know why I didn't do this, but it actually was a very late occurrence or reminder for me is you can literally copy and paste errors and search for those. You might have to add Google script. You might have to add app script at the end of these errors, but go ahead, like Google for them. Literally copy and paste the error, and you'll see documentation, and you'll see people with those errors, and then what the issue is. But I mean, out of all of this, honestly, if this is the one thing you remember, please remember this. If you can only remember one thing, seek out errors. Early on, hit the wrong button, name things wrong, and hit run. See what errors you get so that you know, okay, later on when you think you're doing the right thing and you get an error, oh, it's because I misspelled something. Oh, it's because I didn't have a dot. It's because, oh, this is undefined. This is null. There's nothing here. Oh, yeah, that's not a function. Learn that. I think I talk about this a little bit in some other videos, but one weird thing about errors is that sometimes when you get an error, the actual error isn't in the line or the error that they're telling you. It's just before that. So something just before your code that's running and you get the error, it's actually the thing just before it that is causing the error. So causation of error is going to be interesting to learn and understand. So seek them out. Like find them out early on. See the error that you get when you misspell something. Intentionally misspell something so you can see that when you unintentionally misspell something, you'll see the same error. Speaking of error and error documentation and searching for things, read more. Now, this is something that I had to learn this myself too. Like, the answers are usually somewhere online. In my videos, I'll probably go faster than you expect. Sometimes I'll go faster than you want. You'll have to pause. You'll have to watch that video again. You'll have to see what I do step by excruciating step. I might say something and then do something else or not say the entire thing that I'm typing. So you'll have to pause and retype it. But I'm also very weary that a lot of the things that I do and say are in text somewhere. You can search for them. You can find them. There is an entire huge amount of documentation on Google itself about Google Apps Script. Read it. I did spend, like I told you before, I tried, there were times when I just go through the list of things, read it, and try to memorize it, and I was like, that's so silly. But I would read the documentation to get a flavor of what examples are being used, how do they use that, and I hope, my hope is that Better Sheets is like 10x that, right? The help documentation is going to give you like one example. I hope that over the next few years that there are tens and dozens and hundreds of examples that you're looking for of how to use this formula or how to use this app script, or the use cases of these things are infinite. And I hope that Better Sheets is a resource like that. I'm adding more and more resources literally all the time, more use cases. So if you don't understand the thing as it's written right now, look for more use cases and see it again and again. And I would just say, read more, read more, read more. Keep reading. So if you get through and you're like, I understand this now, keep reading. Read just a little bit extra, see if there's any limitations or anything. And that brings me to the last thing is don't stop. Obviously, we're going to stop after this piece of advice, but I can't tell you how many times I've stopped myself and been disgruntled and dismayed and disillusioned. And I was like, I'll never learn this. Like, I can't do it, right? I'll never learn this is usually a byproduct of like, I can't do this. And like, if you can't do something, keep going, keep trying, never stop, don't halt, don't slow down. Oh, well, sorry, you can slow down. We all slow down. We should slow down a little bit. I should slow down in some of these videos, but don't stop. Keep trying. I'll tell you a little anecdote. When about a year ago, sometime in 2021, I was like, I should build a Google Sheet add-on. It's one of those tools, kinds of tools that I was like, I should probably build one. And I created a Google Sheet add-on, and I put it into like I went through the OAuth process, and I tried to put it on the marketplace, and I got stopped. Like, there was some issue with it, and they emailed me back. Like, this is sort of the normal process is you put it up there, there's some issue with it, and you fix that issue. And it can be like 20 issues, it could be 1 issue, it could be 5 issues. And I literally was like, where is this thing that you're trying to I need to edit this thing? Where is it? And there's this back and forth email literally for weeks and weeks and weeks where I keep asking, where can I edit the thing that you're asking me to edit? And they like would say in here, and I'd be like, I don't know where that is. Long story short, that add-on doesn't exist. I never got through it. But about a year later, just a few months ago, or a few weeks ago actually, I created my first Google Sheet add-on. It's available now because I had gone through that process before. I had gotten stopped, and I was like, I'm not going to stop. I'm going to get this done no matter what. I also had some help. I think I actually talk about this in another video, is I did get some help, right? I read Alice Keeler's great documentation about how to create a Google Sheet add-on that she only put up in 2022. So I didn't have that resource before to read. So I just read that all the way through. I did it step by step, what she recommended. And I went through the same emails of, hey, this is a problem. Okay, I'll fix it. Here's a problem. I'll fix it. And it went through. I didn't stop. I just slowed down for a few months, almost a year, and I got through. So like, you can get through it. And use other people's code and other people's projects, not as like, oh, that is something I want to do, but rather as an example of it can be done, right? If somebody else is doing something that you're trying to do, understand it can be done. They didn't fake it, they made it, and you can make it too, and you can automate your processes. You might have to be a little creative, and don't take this advice, please, of ChatGPT, of breaking down problems. I do think that breaking down problems into its smaller parts is essential to programming, but it's not something like you can really do. Like, you have it or you don't, and actually you might be someone who builds from bottom up or top down, and both of those are perfectly fine. I think breaking problems into its smaller parts is top down, but understanding a lot of different small parts and figuring out how to put them together, that's a different skill set. And I think both of those for programmers are easily acceptable and useful. You might be stronger in one than the other. You might see connections that other people don't see, or you might want to, but I think also you can just do it. You can just try it. So to summarize what I said, to think like a programmer or develop the mindset of a coder, don't memorize anything, understand and learn the process, and know that the documentation is out there. Try things, get it into your muscle memory, do it, go for it, hit that publish, hit that, go run something. Seek out errors, you're gonna get errors. So seek them out early on and understand what they mean, like what the actual words in the errors mean. Read more. You're just gonna have to read a lot more than you ever imagined. Like, I imagine like programming is probably like 90% reading, 10% coding. Truly, like for every piece of code I write, I've probably read like 10x, right? And don't stop. I'm here for you. You can email me anytime. You can also just watch a bunch of videos, right? And see what other people are doing. If nobody else is doing something you're trying to do, email me and let me know what's this new thing you're trying to do that no one on earth has ever tried before. I would love to know. Don't stop. Email me and let me know the new thing you're trying to do that nobody has done anymore, and let me know. I'd be really happy to see some unique stuff. All right, that's how you think like a programmer. You can develop the mindset of a coder, and it won't be overnight. Definitely won't be overnight. Thanks for watching. Get coding. In the last video, I showed you functions, and in this video, I'm going to go into more details about variables. So again, we'll go over to our extensions app script, and we wrote this entire new function here. And let me just delete this and start over. So in our functions that we write, we can write a variable, and a variable allows us to basically simplify a lot of things, or it also lets us repeat things a lot. So we can do variable, and var is what we use here. We can also use const. You might see that if you're already copying and pasting code into your sheets and you see const and variable are very, very similar. In fact, they're almost the same. There are a couple of differences, but we're not going to go over that in this video. But we have a function, and we can have multiple variables. We can have, we can use the word 1 to equal 1. When we assign a variable, we use the equal sign. The equal sign here does not mean is equal to. What I like to do is I like to think of it as the word is. It is assigning the word 1 with whatever we put behind here. We can do variable 2 is, or equal sign 2. And then we can do some math in these functions, right? So we can create a whole new variable 3, that is 1 plus 2. Now, we've only been able to do this wording 1 plus 2 because we've assigned the variables 1 and 2 to 1 and 2. If we had perhaps done 3 or 4 here, even though the word is 1, it is assigned the actual value of 3. And then, just like we learned in the last video, we can return 3. So let's actually look at that now in our spreadsheet. So we got to save. Now all we have to do is call my function. And how we do that is we do equals my function with the parentheses. And we get the number 7. Why do we get that? Is because we've reassigned 3 and 4 to 1 and 2. If we do change 3 to 1 and 4 to 2, save that, we come back, it is now 3. So this function has given us a name to do, and we can get something in return. We can also use variables inside of the name of the function in these parentheses. That's what this parentheses allows us to do. This is sometimes called parameters. I might be using that word a lot. Parameters, when I refer to functions, variables here in this particular case. But these here that say var, those are variables. So these parameters could be 1 and comma 2. So we can add more than one parameter here that can be defined by different things. So we can change our variables 1 and 2 to 1 and 2, and actually we don't need any of these 2 lines. We can delete those 2 lines. Now this variable 3 is equal to whatever is going to be entered into our function on the sheet side plus the other one. So let's see what that is. So let's save this, and we might get an error, but before we get an error, we'll add 2 numbers. We'll do 1, comma 2, and ideally we get 3. But look at this. We can also do 11 and 22. And it's adding those 2 numbers together. So this is pretty simple math that we can do. We can also do very complicated math. We can do something like the function CPM, where we have a cost and views, and we can say variable CPM is equal to, or is, not is equal to, is cost divided by view divided by 1,000, right? And we can return the CPM. We can hit save. And now we have to change this function, CPM, 55, 45, and a bunch of numbers. And we can see we get some CPM here, right? This is very, very powerful because now we can create functions that have completely custom parameters, completely custom variables. We can return information. We can do math inside of these functions. And now we're going to be going into many, many more interesting things that we can do inside these functions. Welcome back. I wanted to take a short moment to talk about dot notation. This is something inside of AppScript that we'll see multiple times later on. We usually see it when we use the function app, spreadsheet app. You'll see that'll be the first time you see it. So we'll do something like this. Again, I'm going to go through this later. And when we get to the end of this word, we add a note, a dot. This dot is a period, right? In our keyboard, it's just a period. We can call it a dot. And what it allows us to do, especially in AppScript, we get this options, which is really, really helpful. But what it allows us to do is take the spreadsheet app, the entire thing that it exists, and we'll get into that later, and figure out what is the one thing we want to do from this. We want to do one action from this spreadsheet app. It gives us sort of a little bit of a way to go into the spreadsheet app. We'll use in the first time you see this, active spreadsheet. There it is. And then when we get to spreadsheet app dot get active spreadsheet, we can add another dot, and this allows us to see what's inside of a get active spreadsheet that we can use. We'll usually use get sheet by name. Again, we'll add another dot at the end, and again, we're inside of whatever the sheet is that we've added. So the dot notation, just I wanted to point out, allows us to go deeper and deeper into the functions. That allows us to do much, much more specific things. Dot notation is incredibly important because you might want to add commas, you might want to do other syntax, but in this particular case in AppScript, we're just going to be using dots or periods to go deeper and deeper into all of our functions. This also appears when we're ever parsing JSON or trying to get sort of a big text document, and we'll use the dot notation as well there to go deeper and deeper inside. And that's pretty much the basic idea. The dot notation goes deeper and deeper inside into the functions that you're using. Hi, in this video, as always, we'll go into AppScript, and I wanted to mention and stress CamelCase. I wanted to mention how important CamelCase is to our writing of functions, how many times we'll get into errors, and it'll be because of CamelCase. So again, CamelCase is this capitalization of words that are put together. It is a way to allow one function to be one word, get active spreadsheet, with no spaces, but we can actually read it. So the G in get, the very first word is lowercase, and then active, the second word is capital A, active spreadsheet is capital S. This CamelCase allows us to read our functions much better, and it also allows the computer to know what it is. If we do something like this, get sheet by name dot get range, we're going to do 1 1. We're going to get into this really soon. This is A1 get value, and then we want to just return this value. We'll call it the 1. So we'll use this variable, as we said here, return. We don't need any variables up here. We'll call this 1, the 1. We'll be writing this out, and I'll be going much deeper into this later. But what this function is just saying it's called the 1 with the variable the 1, and we return the 1. The 1 is the first value in A1. So we put a value in there, equals the 1. Let's see that it works as is. It does. So what happens is if I don't have a capital B here, which is a tiny, tiny little mistake, I'll save it, and we'll go back to our sheet, and we get an error. This error, let me see if I can increase that size, says type error, spreadsheet app.get active spreadsheet, get sheet by name is not a function, and it gives us this line 3 to see. So we can use this error. Usually errors are pretty bad, but in our case, it gives us so much information that we can debug our code. And I'll be getting more into errors later, but this one error is really common when you don't use CamelCase. So we know get sheet by name is a function. We've used it, we're using it, it comes up in the autofill, but what happens is it is literally because it is it should be a capital B, not a lowercase b. It should be all lowercase, all CamelCase, not all lowercase. So we save it again, and this error should turn out to be not an error. Let's redo it, the 1, and we get no errors. It also gave us, by the way, line 3 here. This is line 3 of our app script, and it told us right in the error that the error is in line 3. Now, if it's some type of syntax error or like naming error, yes, usually the error is in exactly the place that the error shows up, line 3. But I will say now, and just give you a little bit of bonus thing here in this CamelCase video, that errors sometimes will error out, but it'll actually be in a line or some variable above it. So that error that you're getting, especially if it's some kind of naming error, will be fine. But if it's some kind of variable error, like gets null, is undefined, those are usually wherever the variable is, not in the error where the error occurs. So just a little note there. But just make sure you use CamelCase. One big thing is that these spreadsheet app, mail app, these large apps that include all of the functions in them are not actually CamelCase. They are, the first character is capitalized, and you'll see this in pink. You'll know if this is right or wrong, if it's in pink or not. For instance, this is lowercase s, it's not in pink, and it is here. Bye. Just like in the last video where I talked about CamelCase, in this video, parentheses, we're talking about one very, very specific thing, but it's so, so important to detail. So again, we'll go up to extensions, app script. We have our app script that we've been working on here, and we will work on in a video or two. But I want to show you, I just want to point out all of the parentheses. In the function name, we always have the name of the function and then two parentheses, open parentheses and close parentheses. These are very, very important. They're almost like a parent warmly hugging all of their children, all of these little variables here. Like you can have 1, 2, 3, not toe, but 2, 3. You can have many variables inside of here, and these parentheses are like a parent. They hug their children. They're very, very, very important. You must have parentheses here, and you must have parentheses on function names, after function names, except almost everything gets a parentheses, except the first one. When we're talking about like spreadsheet app, mail app we'll get to, there's a few other apps that are included in AppScript that allow us to use functions within them. These do not have a parentheses. So if we have something like this, let's see, let's go back and make sure this does work, right? But if we use a spreadsheet app and we put parentheses here, let's see if that actually works. And let's see if we get an error. We do get an error, and what that error is spreadsheet app is not a function, line 3. And this is telling us something that we might not necessarily grok right away. Okay, we can look at line 3 and we're like, what is wrong with this, right? There's spreadsheet app, there's get active spreadsheet, I got parentheses on everything. And the issue is you got parentheses on everything. The first one, spreadsheet app, does not have parentheses. It's not a function of spreadsheet app, it is spreadsheet app itself. Maybe something like this, the one, if we take off parentheses here, we'll have maybe another error. Let's see if it changes that error. Nope, actually we don't get an error there. So we don't even, oh wait, we haven't saved it. Okay, we haven't saved it at all. In fact, we get the error in AppScript itself. It says syntax error, unexpected token. It has a curly bracket, line 1, right here in the file code.js. So we look at line 1 and we're like, well, that curly bracket is correct. Every single function should have a curly bracket. And notice here, I mentioned earlier that sometimes where the error says it is an error, it's actually just before that. And in fact, this is the error, right? The error is not the curly bracket itself. It's the fact that we don't have parentheses. So we add parentheses, open parentheses, close parentheses, and now we save, and now we're able to save. Right? We don't get an error inside of AppScript. We don't get an error here in our Google Sheet. We now have a functional function with parentheses. I wanted to point out while we're here, though, that inside the parentheses sometimes does what there is, sometimes matters. So if we have like a variable range here, and we're trying to get like A1, and we're doing get range, because we can use a variable for that range, we're going to get an error if we run it from inside of AppScript. Let's see, we'll have to review our permissions. We'll do this again later. I'm not going to walk through this right now. just get through this. We could probably get an error. Yeah, argument cannot be null, A1 notation. So what this is telling us is that actually right here, this line, range and range, there's nothing there. It's a variable. A variable must be filled with something. So this doesn't mean that our function is wrong. It means that we're running it from the wrong place. So if we put inside the parentheses here, the one in quotes A1, that gives us the actual value of the variable. So now this range is A1 and this range is A1. So we get through this argument and the error by actually adding something that is defined, which is A1, but we do it inside of the parentheses here. Again, we're going to get deeper into this and how these variables work, and you'll see this multiple times over and over and over again with variables inside the parentheses, without variables inside the parentheses. Sometimes we want them, sometimes we don't. Sometimes it's all sorts of things. So check out, like, if we use sheet 1 here and we don't use quotes, it looks pink, not that like brown. So that is going to be a problem. And let's see what we got here. And we got an error, and it says error, sheet 1 is not defined. Perfect, because we need, inside these parentheses, we need it in quotes. Sometimes we need it in quotes, sometimes variables don't have quotes. But if we have actually like an actual string that we want, we put that in quotes here, just like we did here with A1 in quotes. All right, thanks for watching. Now on to more. I'm so glad you got through all of these videos. Hello, welcome to the first actual lesson of Spreadsheet Automation 101. You've gone through the pre-course material. Maybe you've even gone through the Learn to Code course that I offer. That's about 38 minutes. That's 6 videos. It shows you very quickly all the way through how to code in Google Apps Script here. But in this course, we're going to go a little bit slower. We're going to go a little bit more specific. Today is a pretty cool thing. We're going to write code. So you can do this a couple of different ways. One, you can follow along. We're just going to go up to Extensions, App Script. You can pop this over into another window and open a sheet.new, and App Script is available to you right from the get-go. So you create a new sheet, and you have this function, my function. We're going to write code right now. We're going to create a code that takes the A1, whatever value is in A1, and brings it anywhere else in the sheet. And what we're going to use to do this is something called Spreadsheet app. So Spreadsheet app with a capital S and a capital A with no parentheses is a set of built-in functions inside of AppScript. Now when we hit the dot, the period, and we have this autofill, we can see all of the options that are available to us. And this is pretty cool. It gives us autofill. It makes it faster to code later on. The one thing we're going to do right at this moment is get active spreadsheet. I'll go deeper into this in another video, in the next video. And what this does is it gets the spreadsheet file that we have right now open. So all of this entire file, sheet 1, all of the tabs involved, everything, we're going to get active spreadsheet with the parentheses. We're going to do dot. So a silly mistake, we got to get active spreadsheet. And now when we do another dot, we have this. If you had what I had, which was set active spreadsheet, you'll notice the autofill doesn't show up because there's nothing left to do. We can set active spreadsheet, but we actually have to get the active spreadsheet. And now when we hit the dot, more things show up. The next thing we're going to do is we're going to get sheet by name. We can start typing it, get sheet, but then we can also select it here and get sheet by name. Again, you can type this all out if you want, or you can follow along and try to do as I do with the autofill. Add the parentheses. Make sure you add the parentheses. And we're going to get the sheet by name. We got to actually put something in here. In quotes, if we hit the first quote, the second quote will show up. We're going to do sheet 1. That is literally, we'll flip over here, is the name of the sheet. Now, capital letters do matter. If you watch the pre-course material, you'll know that. So sheet 1 with a capital S in quotes, get sheet by name, and then we're going to get range. The range we want is A1. Now I remember we got to rename our function. We can use my function, but we can also get A1 from sheet 1. We'll name it all of that. Okay, we're going to hit save. We should hit save early on because the first time you hit save, it's going to take a little bit of time, a little bit of moments. But now we get range. So what this allows us to do is get that cell A1, but we still need one more step. We need the final step is get value. That's the name of this whole section is get value, and that's why. It's because we actually have to get the value from the cell. We'll hit save. Now what this is doing is in this function, it is literally just getting the value, but we actually want to see it. We want to return. So again, from the pre-course material, you'll know we need to actually do something. Return. And what do we need to return? Well, we'll set a variable, the value, we'll call it. We can literally call it anything we want, almost anything. There are some saved words like name, var, val. We'll turn the value. So again, we can type in any text here, but we just have to make sure it's the same text here, return. So now every time we do get A1 from sheet 1, in here we'll do the same thing as we do every function or formula in Google Sheets. We'll type a equal sign and then parentheses once we have the name, get A1 from sheet 1. We'll hit enter, we'll see what happens. And that literally loads whatever is in A1. So we can change that, the stuff in A1, and we have to hit this again. We'll get that again in another cell. See, this is a little bit cached, so sometimes you might have to copy it, cut it, create a blank cell, and then paste it again, and it'll go again. The stuff in A1. So anything in A1, we can get anywhere else in the sheet with this exact code. So I thought getting a value was the best part of this is get value. We're going to go a little deeper. I'm going to go in the next video more about strategy and concept of what Spreadsheet app does and what this entire row of code does. Join me in the next video. Hi, welcome. In this video, we're going to jump out of Spreadsheets for just a moment and go into a slide and try to present to you what that Spreadsheet app and all of that code that we did before, Spreadsheet app, get active spreadsheet, get sheet by name, get range, get value. I want to show that to you. Instead of just typing it out and you typed it out yourself and it worked, that's sort of the same as copy and pasting the code. I want to actually try to get across to you what this is doing visually. So I made a little bit of a slide here. Let me move my face around. All right, what makes a sheet? Let's find out, right? And what that is it's just rows and columns and cells. The code, app script, that we actually program is integrated inside of the spreadsheet file. So all of the code that we do in app script, especially when you start into spreadsheet and you go to extension app script, that's all code inside the spreadsheet file. That spreadsheet file includes all of the sheets, it includes all the tabs, all of the cells, all of the rows, all of the columns, everything in that entire spreadsheet file we can access. Every sheet, it has some rows, every sheet has some columns. Now, A is equal to 1, the first column, B is equal to 2, the number 2. We'll get into that in the next video, actually, a little bit more. And each cell, every sheet has cells and can be referenced two ways in code. You have A1, A2, B1. You also have 1, 1, 1, 2. Again, we'll jump into that in the next code because that's a little bit, it's hard to tell you. It's easier to show you. All right, we already went over dot notation, and that's what we're going to use right now to go from Spreadsheet app down to the cell. So Spreadsheet app, the pink part here, right? This is not black. It doesn't have parentheses. It is Spreadsheet app. It is a whole set of functions pre-built into Google Sheets that allows us to access a lot of cool stuff. So that Spreadsheet app means the entire file, everything, all the sheets. If we do dot get active spreadsheet, we're getting the spreadsheet that we are on right now. That is still all of the sheets, all of the tabs, everything, but it's just saying we want the spreadsheet part of that. Now, if we do dot get sheet by name, we are selecting one of the tabs by its name, and we have to put in quotes exactly the name and spelled correctly and the correct capitalization. Sheet 1 or sheet 2. We have to put in exactly the name of the sheet in quotes inside that. But now, see, we're going a little bit deeper each time. Every time we add a dot notation and a new function, we're going a little bit deeper, down into the rabbit hole. The next thing we could do is get a range from that tab. So We are here on sheet 1. We have a range, any types of ranges, rows, columns, ranges, one-dimensional arrays, two-dimensional arrays. We have all types of stuff here we can get. But we can access that range with A1 notation, meaning we can literally type in quotes A1. We can also do one-on-one. We'll get into that later. Once we have the range, the next thing we do is we get the value of that range. So we usually, at least at this moment, we're getting one cell. So when we do .get value, we're getting the value inside that cell. So back to our function, we just went all the way through this, right? Spreadsheet app without any parentheses, .get active spreadsheet. And we can sort of look at it this way, right? This is all one line, but we can also put it on separate lines if we want, I do believe. And we can see how visually, right, from the entire spreadsheet, we go to what is the active spreadsheet? What is the spreadsheet file that we have open right now? What is the sheet inside of that file? And what is the range inside of that sheet? And then what is the value inside of that cell, or that range, right? Now we can change the sheet name. We can change it to sheet 2. We can change A1 to B1. These are all fungible, flexible. We can do all sorts of things with this, right? We can also, you mentioned in the pre-course material, we can have like a range here. And we can put range right here. We can also have a sheet, perhaps, and we can say, in the function on the sheet, we can say whatever the sheet is, and we'll have that variable pass through all the way here. So this function allows us to do lots of things. It's very flexible. It allows us to get all the way down to the exact value that we want, where we want it. In the next couple of videos, I'm going to go deeper into a couple parts of this particular script, and we'll see how that goes. So I wanted to go into more about this A1 notation and how it can be replicated or changed to row, column, and also why. So in our last formula we created here, we have a range, we have a sheet, and when we type in this get A1 from the sheet, we have A1, and the sheet we have a sheet 1. And hopefully we'll get that stuff, right? The stuff that's in A1, we get it here. Cool. We can do that anywhere, right? But this A1 notation is a bit limiting in code because we need to know the column number, the column letter, and the row number. We have to actually do that. And in a string, too, that's really unfungible, to be exact. So sometimes what we want to do, instead of this range, we want to do something like 1, 1, which looks like 1, 1. And what this is calling the first number means the row, and the second number means the column. Now, when we have an actual number, we can do really cool things with this. We can get the last row and put a number there. We can get the last column, put the number there. Sometimes we might actually want to get a column, and we're like, oh, we want everything on the K column, and we're like, what number is the letter K? One simple thing you can do is equals column, and put the parentheses, and it'll tell you right there what column it's in. So that's 11. So the K column will be 11. And we want to get that value. And now we can also change this back to, actually we don't need to change it. We can save it. And now we're going to get what's in K1 equals, let's get that function name correct. Now all we need is the sheet 1 here, and we're going to get the K column. Ideally, right? 11, perfect. That's getting whatever value is here. So we can type in any value there, redo this function, and it'll call exactly that information there. So what this does is allows us to really change it and make it more flexible. This row, again, it's row first and then column. There are 4 potential options you can do with this range. Whenever you do get range and you start typing like a number, if you start the open parentheses, it will tell you some options here. So we go 1, comma, and 1, so that's row and column, and that's if you only want one cell. But let's say we want a number of rows. We hit, again, the, let's see, I want to bring this down a little bit. You should be able to see this easier. There you go. It's actually even more up there. Wait, maybe I'll do that. Oh. You should be able to see this. There we go. The number of rows to return, there's a little bit of still up there. There's a lot of information here. There we go. So we have row number, column number, and right here, okay, here at the very top, get range, we have these options. So we have the option of only doing 2. We also have the option of doing 3 variables or 3 items, elements in here. We can say the number of rows, let's say 20 rows. We also have the option to add a 4th thing, which is the number of columns, and we can add any number of columns. 1, 1 will be on row 1, column 1, and the range will take 20 rows and 20 columns. You can also do 2, or we can also just do 1 row and 1 column. Maybe we want to do 20 rows and 1 column. So that's one entire range of column, like the K column, in fact, would be 11 here. So it might be a little hard to discern this, right? To figure this out easily, let's face, right away. What might be the most beneficial thing to know, how to do range, this sort of row column range, is just to try it, right? Try to call different ranges like A1, B1, B2, or K1, or K, or F55, and see if you actually get the correct one, and try many different ways. Again, just to rehash this, the range has 4 potential options. Minimum is 2. We also can do 3 or 4. So we can say row 1, column 1, or actually let's do 2. Row 2, column 2 would be B2. But let's say we want to go 3 rows down and 3 rows across from starting at B2. And that's what we do here, 2, 2, 3, 3. So again, try that a few times. What you might get is that right now we are getting a range and we're only getting 1 value. In a later section, we'll do get values. So stick around for that. That's going to be really cool. We're going to work with arrays. That'll be in the next section. But in the next video, we will talk more about something else, getting active spreadsheet versus get active sheet. It is a mystery that I was having to solve. I had to solve for years, but I want to get you up to date about it faster than I got it. So watch out for the next video. Welcome. In this video, we're going to cover something that literally took me years to figure out and I didn't know the difference of, but I want to get it across to you very fast and very soon before we get any further. So in the last couple sessions, we've done this Spreadsheet app.getActiveSpreadsheet, and we're going down further into the sheet by name, get the range, get the value. Well, this function, as we have it written here, is actually very good for running scripts. That's what we're doing here. We're automating AppScript, and we're going to be automating AppScript in the next few sessions, in the next few lessons. But I want to point out something, that this function is not necessarily the best if we are creating scripts while using the sheets. This is great for running scripts when we're not an active user, but if we are an active user, we're going to do something a little bit different, and you actually have a choice. You can do it like this, or we can take get active spreadsheet and change it to get active sheet. Literally, that's all we have to do. Let's add a few more space so we can get that up here. So this is the same function. Actually, we'll do 2, right, to make it a different function. Recall from our pre-course information, we can only have 1 function as the same name. Every name has to be unique. Okay, there's one problem with this. As is, all we did is we deleted the spread from get active spreadsheet. But get active sheet is going to go to the user, whoever the user is. In this case, it's us right now on the sheet. It's going to get the sheet, and we don't need the name. It'll know the name. So we actually delete this whole line here as well. So get active sheet does sometimes seem simpler and faster, right? Because we're a user. We're going to go here, get active sheet from sheet 2. We don't need a range here from sheet we're on. Let's say, actually, that's a real name of it. And anytime, this will be A1. We're on a sheet, so we'll add a new sheet. We don't have to do sheet by name. Do equals. Let's see if it works. And it does, right? So what we're doing is if we want an active user to run the script, we don't need get active sheet. Sorry, if the script is an active user, meaning someone's using it right now, we do want get active sheet so we know which one we're on. We don't have to put the get sheet by name. Okay? It goes wherever the active user is. It can be sheet 1, it can be sheet 2. You can change the name of the sheet. Get active sheet sometimes seems great, but the one problem is going to happen when you try to run that script and no one is an active user. So it's a tiny difference, get active spreadsheet versus get active sheet. But a big difference is that you do not need to have the get sheet by name part of this. And if you have an active sheet, you have to have an active user. Okay, so the first one, again, get A1 from sheet 1 is more specific. It tells us get this sheet by name, get it at this particular range, but it allows us to do that automatically all the time when we run automations and triggers. Again, we'll learn that later. So tiny difference, but big possibility difference. And I didn't realize this for years. I know this now, but yeah, get active sheet gets you the sheet that you're on as a user. Get active sheet, you can get that range, you can get the value, and you can go all the way through all the steps we did before, going functionally down and down the rabbit hole. You can still do same as before, get active spreadsheet and get active sheet. Have the same, get range, get value, all the things. But it's just a little bit of a difference that makes a big difference later on. Thank you for watching. Again, next video, we're going to do our first trigger. You'll see the very first trigger we'll do, which will be exciting. We are going to start into our first trigger, the very first real automation in Spreadsheet Automation that you can do. So triggers are able to do a lot of different things. In this case, it's a simple trigger called onOpen. We can write this inside of our app script. So let's go to our app script right here, extension app script. And all we have to do, we can do this on a new script if we want. For the purposes here, I want to just add some lines up here and write it here. Now, onOpen can be function on with lowercase o here and then an uppercase onOpen. And we have our function here. But I always forget how to do this, and I always forget what I want to do on an open. So in this particular case, what we want to do, little fun thing, is we want a custom menu that every time this spreadsheet opens, it adds a custom menu here, and we can access scripts from that menu and run them. Because, as I sort of mentioned before, actually maybe in the pre-course information, functions that we write in AppScript can be done here. We can do an equal sign, type it out, put it in there. We can also run them from inside here. But another place we can do is a custom menu, and we can run it directly from this sort of area, the front end of our Google Sheet, and we can run functions directly from here. What kind of functions would we run from here that would run, maybe copy paste, maybe logging, tracking, any kind of sort of maybe deleting some rows in a particular way or adding some rows with some formatting, lots of different things we want to do. Once we have like an active range and an active spreadsheet, we're like, oh, maybe we want to duplicate this spreadsheet, but we don't want to do it as this duplicate. Maybe there's extra things we want to do, duplicate and change something. We can run that from a custom menu, but I always forget the exact syntax of custom menu. So I literally go to Google's help here. You can type in custom menu Google Sheets, and the very first link will be this custom menus in Google Workspace, this link here. We scroll down and we have function onOpen. We can literally copy paste all of this. We can copy paste all of this if you want to see actually these. So let's copy the whole thing. And I'm going to paste it over this. Again, we cannot have more than one onOpen function here in our sheet. So I'm going to save this, and exactly as Google has this custom menu and this sort of sample here, the one thing we have to do though to get this is we have to open the sheet. But the sheet's already open. So we're going to refresh the sheet. Our app script goes away. You must save the app script before you do this. But once we reopen this, you'll see this custom menu pop up here in the top right, in the middle sort of. So how do we edit that? We can go back to extensions app script. Let's look at it though. Let's see custom menu, first item. Let's click on it. It runs the script. It asks us for some authorization because I think we have some spreadsheet app in there. We always have to run this authorization the first time we run a script from this menu. You click the first menu item. So it gives us a little prompt, gives a little okay. Let's see what happens when we click the submenu, second item. Click the second item. So something happens. The script shows us something is happening. It's running that script. And now we have a custom menu. This is really, really cool. We can rename this custom menu. We can say, automations, save. We have to save, and then we have to reload it. Right now it says custom menu, but it only runs on open. So we'll have to refresh again. And wait for it to pop. It takes a moment or two to pop up. And here's our automations. It's renamed. So we have to open our app script again. Let's see. And this on open, we can also edit how many items are here, which items are where they go. We can name something so it shows up one name and use the function name that it will actually run here as the second item. So if we have if these were actually functions we want to run without knowing, an active range, we could put that get A1 from sheet here. So we can sort of write another one. Function show A1. Let's do that. And what we need to do is we need to get all of this value stuff from A1, but we don't want to return it. We want to get this UI. Same thing here. We'll just copy paste that. So what this is spreadsheet app.getUI, and instead of any text here, we'll write the value. We can actually string together some information here. A1 colon space and then plus the value. So let's see what that does. We have show A1. We need to add an item. So we can add item. The first one will be whatever the text we want to see. So show space A1. Then we want to do a comma. And here we need the exact function name here with no spaces, the same exact name. So let's save that. Again, we can hit save project as well up here. We're going to, we don't have a second item here, so we need to refresh. It needs to run that again on open. Wait a moment or two. And here's our automations. Show A1. Sheet is not defined. Let's go back and see what our error is. Dismiss. Extension app script. We probably have the word sheet, not sheet one, maybe, I think. Show A1. Yeah, we have the word sheet. And here we need to write capital sheet 1. We can also do get active, but for now, show A1. And I don't think, because we didn't change the name of the function, and we didn't change the custom menu here, the on open, we don't have to refresh the page. We don't have to reopen the page. So let's see if that works. There we go. The stuff in A1. That's literally it. Here, hello world. Automation, show A1. It's going to grab that. Hello world. There we go. Perfect. So we have worked with Spreadsheet app. We figured out the difference between active spreadsheet, get sheet. We've created our first trigger, which is an on-open trigger that opens a custom menu every time that we open the sheet. We are rocking and rolling. Really excited about the next. I hope you're excited about the next parts, and we're going to go off and we're going to get more than one value in the next session. This was get value. Now let's get values. So when we're creating sheets and we're adding some functions and formulas to our sheets, sometimes we want to do something in the future, but we know that we want to do it, and so we can set up some formulas. And I've been doing recently a lot in Spreadsheet Automation, using AppScript, using code, but I wanted to go back to some formulas that I think feel like magic. They feel like automation. They really seem like you're adding automation to your sheets, meaning that if you as a user or another person using your sheet takes some action or enters some data, something happens based on that action. So as a result, like an effect, right? An action and an effect. Now, we can do a lot of this in AppScript, but if you're uncomfortable with code, if you're uncomfortable diving into AppScript using onEdit, onOpen, and these sort of built-in functions, and you're sort of not really convinced you want to learn to code, I want to give you some interesting formulas and formula pairings that help you make essentially automation inside your sheets. They will at least seem like automation or seem like magic sometimes. First off is the if. And we're going to go through all four of these: if, flatten, IFERROR, filter. We're going to talk about transpose and unique, one of my favorite types of things to do because it sort of creates headers. If, we're going to create literally something out of nothing. Flatten takes a bunch of like mangled data, turns it into a single array, and we'll talk about that, or column. And IFERROR and filter is really cool because you can set up filters before you know someone's going to fill it out, and then as if like magic, their information is filtered once they sort of go to another page. So we'll get into this. Let's get into it. Let's start off with the if. The simplest way I can show you this is if we create like a to-do list or task list inside of Sheets. And we have a checkbox here. Coolest thing about checkboxes is that they are a visual representation of the values of true and false. We can create in here, we use equals, if. A logical expression in our if formula needs to be something that ends up being true or false. But checkboxes are true or false. So we can just reference the checkbox A2. Now, if the value is true, meaning it's checked off, it'll show something. If it's false, it'll show something else. So one thing you can do in this particular case is say, if it's true, write some kind of like done, like a word. And if it's false, we can sort of just say whatever, like task 1 here. Whatever the task we're trying to do. What that allows us to do is when we hit this checkbox, this is done. We can also conjure it from nothing. So we can write this all the way down. We can also put all of these tasks on a separate tab and then reference their cell here. Instead of the word task 1, we can reference a cell like B2 here. Now, as we go down, you'll see that these are done. So we can keep this B column on another tab if we really want to. But we can see that this is done, right? That changes our text just based on that action of checking off. But we can also show things. So let's say we don't want to see task 2 through 10. Basically, we don't want to see the next task until we're done with one. So what we can do is equals, same thing, A2. But in the true, actually, we'll do task 1, we'll leave as is. For task 2, we'll do equals if. Our logical expression is going to be the row above it, A2. And we're going to say, if the value is true, show task 2. If it's false, meaning there is no check mark, we are going to do nothing. We're going to leave this absolutely blank, right? After the comma, we don't do anything there. And we're going to hit enter. Now, when task 1 is done, check, task 2 shows up. So we're going from nothing to something. We're literally conjuring up here this task 2 based on the checkbox on A2. And we can do this all the way down. Again, we don't have to write in the string here, the words here. We can reference something else. So we can reference, say, B2, or B3, sorry, here. And we can do this all the way down. So now, I copied it. There are formulas here, but it looks like there's nothing. And as we go, task 2, we're done. We show up task 3. All right, click another one. We're done with that. Task 4 shows up. This is a really cool way to really bring some automation in, right? Show the next task when the task is done, or some kind of approval steps. You might be able to do some like fun quizzes in this. Really some cool use cases here. That's if, and we really conjure something up from nothing, something from nothing. Now, flatten is a little less exciting, I will say. Let's create another tab, and we have some, task. Maybe we're writing down our notes, but they're in like many different columns, right? We have sort of this data that's mangled up. We have task 3 here. We have task 4. We have task 5 up here. One of the interesting things is with Google Sheets is sometimes, maybe not interesting, maybe one of the heartbreaking things is we will use somebody else's data, right? Somebody else will put something in a sheet and we have to analyze it. We have to manage that data. We have to like figure out, wrangle it up, right? Like a cowboy with some stray cows or some stray sheep have gotten out. And of course, if I wanted to put this all in a list, I would do something like task 1, task 2. I would just like look at these and write them somewhere else. And this is going to take a while. But what I can do is equals flatten. And what this will do is we'll take the whole range here and see now everything's in one column. Now, there does include the blanks here, right? Because sometimes our data is absolutely full. Like we have task 2, task 3, task 4, 5, task 6, right? And if we do it like this, it will actually, if these are all in order vertically, but we're putting them all in one column, this will end up being, actually, it has to go across. Sorry. So you see here, task 1, task 4 is across horizontal. Each row is getting the column, and then it's adding them together, all in one column. This is really cool. Again, if you have a whole bunch of mangled data, you would also want to have something like sort, perhaps. You can sort this sheet, and do something like this. You can also sort. That will help you. But this flatten is the key here. Flatten is going to take a wide array of like ranges, right? A two-dimensional array or range, right? Columns and rows. And it's going to put it all in one place. This is really cool because we don't have to put flatten in after the data comes in. We can put flatten in a sheet or maybe on another tab and say, okay, here's 3 or 4 columns that you're going to put any information you want here. And then on this other tab, it's going to capture all of that and put it in one column. Very, very useful for certain types of tasks or data entry when you're not really sure, like maybe you just want to see a wide range of data here. Very, very cool to add flatten somewhere where the data that's coming in is across many different rows and many different columns specifically. All right, the next one is a formula pair, if, error, and filter. Now, what happens with filter, we'll do something like this. We'll actually we'll rename these. This is if, this is flatten, and we'll add another one, filter. You might be familiar with filter, but I want to show you one extra thing you can do with if error. Basically, task 2, task 3, maybe there's task 4, and we go equal, and then we're like done. We'll write done here, done, and then in task done. We can do equals filter. We're going to filter out a column, but we're going to say only ones in the A column that the B column is equal to done. So we only want to see the done ones, the done tasks. And we can label this done. Now this is cool, right? We can add this filter in. And now if we have a list of tasks, we can even increase however many are here. As we get them done, we get a list here. We don't even have to spell done with a capital D. If we get our tasks here, they will automatically show up in this filter. That is if we use the filter for the entire column, right? Here is the problem. If we have no tasks done, if this filter is empty, we're going to get an error here. And the error is NA. It means no matches are found. So it's not really a real error. I mean, it is literally an error in that there's nothing there. It can't show anything. But it's not an error because we're going to fill in something. So you can wrap if error. You can use the formula if error, wrap it around filter. And instead of saying like some text here, like you can literally do nothing. You can just add that comma, hit enter, and now it's blank. So it doesn't show anything until somebody starts typing in done, right? Where we have these done tasks. Done's not done's, done. Now that's pretty cool, right? It's essentially conjuring a filtered list based on your list that you have here. Like that's really cool. You don't have to show the filter. You don't have to show an error. You can do if error. I'll show you one extra thing. If, however, you do encounter other errors other than NA, and you want to show that. See, if error is going to happen no matter what the error is, but we actually know the actual error is NA. So you can do if NA here. So if NA is essentially the exact same thing as if error, but it will only do the if, it'll only cover the if NA error. And that's really cool, because then if for some reason our filter, we actually do have a problem with this syntax, if we have a problem with it here, it will show up and we'll see, okay, we have an error, we have to fix that. And so if NA is sometimes better if you're unconfident about your formula typing and your syntax. And I would always recommend doing it first without the if error or the if NA, just do filter alone, get the error, and then put the wrapper on it. That's what I would recommend. Cool. Now, transpose and unique. This is probably one of my funkiest and funniest flavors of formula pairings. It's using transpose, which is a really fun, weird formula here. Let's retype that, transpose. Better? Transpose. All right, transpose, what does it do? It takes let's do our task list again. Task 1, task 2. Let's create a few more. And if we do equals transpose, and we just take in B1, B2 to B6, what does it do? It puts everything horizontal. It literally just changes from a column to a row. Well, if we have some kind of categories, let's say for these tasks, like there is home tasks, there is office tasks, there are, baby, we have to take care of the baby for some of these tasks, and we're like, we want to prioritize, let's say, the baby stuff today. Like we have a task list and we're like, here's our categories of what this task is, what this thing we need to do. And we want to create what's sort of like a Kanban board or a Trello board, it might be, where we have home, office, and baby. And we'll list underneath here, we'll use our filter. I actually have a whole nother video about this. Check out Kanban board or Trello board in Better Sheets. I have a whole nother video about this. We'll put a filter down here. But this headers here, what happens if we end up having like a different task, right? We have a car task we add. We could programmatically or automatically add that to this header list, and that's how we use unique and transpose. What unique does is we'll take all the unique of a column. Here is all of our unique. Now, if the car didn't exist, it would only show home, office, baby. But if we add car, this unique formula is automatically bringing in the car. So this is a list, right? But we want it as headers. You might be yelling the answer to me right now. You might be like, it's transpose because I just showed that to you, right? So what we can do with our unique is wrap it with transpose. And let's see what happens there. And now, suddenly, we have all of our headers in exactly the way we want them, and specifically in the order that they are vertically, they will be uniquely as our headers. And all we're doing is taking transpose and wrapping that around the unique formula. This is really cool. Now, again, if you want to check out the actual Kanban board video, go check that out at Better Sheets. I have a whole video about using filter here and this particular formula pair. But this one was supposed to show you automation-esque kind of things. Bring a little bit more automation to your sheets without knowing AppScript. Again, if you are not confident about AppScript, or you're interested in AppScript and actually automating your sheets, I just released Spreadsheet Automation 101, and I think if you're watching this video, I'll be putting this video actually part of that course. There's 29 modules already. It's just less than 3 hours. With this video, we're going to hit over 3 hours of content over at Spreadsheet Automation 101. Check it out. It's available right now on bettersheets.co. If you're a member, if you're a lifetime member, you have automatic access to it. But also, if you're not a member and you're watching this, say, on YouTube, go check out Spreadsheet Automation 101 and on Udemy. It's available on Udemy. Thanks for watching. I hope you're just now getting excited about AppScript and automating your spreadsheets. If you want to get the entire full course of Spreadsheet Automation 101 and learn even how to access APIs, how to access different triggers, then check out bettersheets.co. There is Spreadsheet Automation 101 there. If you are looking for a full master course on automating everything in spreadsheets you possibly can think of or you can't think of, check out Master Spreadsheet Automation over on Udemy. I teach that, and it's over 19 hours of content at last count, and I'm adding content all the time there. Go check it out and enjoy. I hope you have caught the bug of automating and writing code in AppScript.